Okay, let's get into this. We're doing a deep dive focused on just a few days, right? June 11th to 13th, 2025.
That's right, a very specific window. But, well, what happened in those 72 hours globally is quite revealing.
Yeah, your sources paint this really intense picture. So what can looking at just 3 days actually tell you about the bigger climate story?
It's a powerful way to see it, actually. You get multiple really severe weather events hitting different continents all at the same time. It's like a concentrated look at a planet under, well, pressure.
Right, under pressure. So our goal here is to explore that snapshot, see what was going on, and then, connect the dots to the climate science. Let's start with the specifics from those days. What stood out?
Well, the picture is pretty intense. Central Europe saw fatal flooding.
Yeah.
Really severe. Sources mentioned it actually changed the shape of the land in some areas.
Wow, changed the land. That's significant. Okay, and then halfway across the world, Southeast Asia.
That was extreme heat. Described as unprecedented, long-lasting, very intense heat wave. We're talking heat indices, so the feels like temperature getting up to 42, even 52 degrees Celsius.
Just brutal heat. Meanwhile, North America wasn't quiet either.
No, definitely not. Persistent severe thunderstorm threats, hail, strong winds, even tornado risks across large areas, and also significant flash flooding worries, particularly in Texas and parts of the Midwest.
So floods, heat, storms. And what about tropical systems?
Yep, those were in the mix too. Tropical storm Wu-Tip was active over near East Asia. And importantly, the forecast for the Atlantic hurricane season was already pointing towards above normal activity.
And they link that directly to ocean temperatures.
Explicitly, yeah. Driven by those record warm oceans we've been seeing.
Okay. Anything else adding to this global picture?
There was actually one more thing, alerts for G1, G2 geomagnetic storming, solar activity.
So space weather too.
Yeah, a reminder that Earth systems are connected in complex ways, though obviously the main driver for the floods and heat we're talking about is atmospheric.
Got it. So that's the snapshot. Intense, widespread, hazardous conditions all crammed into just a few days. The big question then is this just a string of bad luck? Or is climate change the underlying story here?
Well, the scientific consensus, it's really clear on this. Groups like the IPCC, the WMO, they state unequivocally that human activity, human-caused climate change, is boosting the frequency and the intensity of many extremes like these.
And the mechanisms, the how behind that link, are pretty well understood, aren't they? How do your sources explain it?
They focus on a couple key things. First, a warmer atmosphere just holds more moisture. It's basic physics, about 7% more water vapor for every degree Celsius of warming.
Right, so more water available to fall as rain.
Exactly, leading to heavier downpours, increased flood risk. And for things like hurricanes, warmer oceans are like fuel. We hit record global ocean heat in 2024, and the rate of ocean warming, that's more than doubled since just 2005.
Doubled since 2005, that's fast. And can scientists link specific events, like those floods in Europe, directly to climate change? Attribution, right?
That's the field, yeah. Attribution science. Now, for these specific June 2025 floods, the sources didn't have a dedicated study yet, but they did reference a very similar event in Central Europe back in September 2024.
Okay, and what did they find for that one?
Studies on those floods found climate change made them twice as likely to happen and about 10% more intense. So while it's analogous, it strongly suggests climate change played a significant role in the June 2025 event too.
Makes sense. And the Southeast Asia heat wave, was that link clearer?
Oh, absolutely. Very direct. Scientists cited in your sources were explicit. Many days of that extreme, prolonged heat were made worse, exacerbated by global warming. A very clear signal.
Okay, so the extremes are happening. The climate link is clear. Let's talk impacts. What does this actually mean on the ground, and how are we coping?
The impacts are, frankly, devastating. Fatalities, like we mentioned in Europe, people forced from their homes, huge economic damage, farms, roads, infrastructure, and just immense strain on emergency responders, on healthcare.
And these things often don't happen in isolation, right? They can compound each other.
Exactly right. Your sources give examples. That heat wave in Myanmar hitting people who were already dealing with the aftermath of an earthquake, maybe without power or shelter, or, extreme heat hitting Southeast Asia right during their storm season, multiple crises piling up.
It's a lot. Now, early warning systems, EWS, they must be crucial. Do the sources say they're helping?
They absolutely save lives, vital tools. But there's a big but. The sheer scale and intensity of these events now, sources describe them as severely testing and in many cases overwhelming, even good systems.
Oh, overwhelming them.
Yeah, like even with the warnings for those 2024 floods, the magnitude was just so massive, it pushes systems to their limits or beyond.
And there's a global inequality issue here too, isn't there? Not everyone has access to these systems.
That's a critical point highlighted. A third of the world's population lacks adequate early warning coverage. And it's the most vulnerable nations that are often left behind.
A third? Wow.
Yeah, and the data shows disaster mortality rates are 8 times higher in countries with limited EWS. It's a stark gap in preparedness.
So looking back at that June 2025 window, it wasn't just a few bad days. It's a signal, a clear one, from a world changed by climate change. It shows how warming fuels these extremes, how it strains our ability to respond, and how the impacts hit hardest on those least prepared. So what does this intense snapshot tell you about the preparedness we need, not just for the next few days, but for a future where this kind of intensity might be, well, more common? How do you build resilience when the baseline itself keeps shifting? That's something to really consider.